So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says overlapping intervals. This problem is very similar to one of the lead codes problem. If you are unaware, you can click the video which is shown over here. The only difference is here that we here have a array list to return, and we don't want it to do this in place that fields. And similar thing is within lead code, but with a primitive types, and we are okay to overlap, and we are okay to modify the array. Maybe we are okay to modify the array here as well. Let's see how it goes. So I'll give you a guess about question. The question says that we are given an 2D matrix or a two-dimensional array which is representing intervals, where each entry ARR of I says it's a start and end, and our task is to merge all the overlapping intervals. You can see very well that 1 3 overlaps with 2 4, and hence we have a common or a larger interval which is 1 4 below here. Next we have 6 8. 6 8 doesn't overlap with 9 10, so we have individual 6 8 which is over here. Then we have 9 10 which is kept as it is because no other interval is beyond. Similarly, we have 6 8 1 9 2 4 4 7. You see 1 9 is the result here, because 1 9 captures each and everything within the interval. That makes sense. Now how can we approach this problem? So such kind of problem are categorized under the proper format of greedy algorithm. So these kind of algorithms are known as greedy. So such kind of algorithm requires you generally to take the optimal or perceived, I'll say perceived correct route. So that would make our next steps clear, which would make next steps clear. That means what can be something correct route which we can take, or correct sequence which we can do for such algorithm to make our further life easier. So in this example versus this example, I want you to tell me the difference. What is much more simpler to go ahead and solve the problem for? I'm not asking anything implementation. I just want the way how you can go ahead and approach this and what feels better. We have already discussed example 1. Let's discuss example 2. How can we do it? We have 6 8. Now in the naive method, I'll compare 6 8 with the next upcoming 1 9. So I'll have 1 9. That means I'll ultimately have 1 9, and then I'll have 2 4, which is integrated again with 1 9, 4 7, which is again integrated with 1 9. Cool. What if I didn't have 1 9, but I have somewhere 6 3 and 1 9 here, and I'll do one thing. I'll have 4 7 over here. So having such kind of thing would obviously would not be better, because I'm compressing this both intervals, then I'm looking forward for this 2 4, and I'm not getting any output from here. Let's take it 3 2 3, because post merging this two, I'm getting this as 4 7 4 8, and next interval I'm getting here as 2 3, and next interval I'm getting here as 1 9. Again, the result which we have got upon a single parse, so single parse is required, is not fully correct. Okay, we are correct to one extent that we have merged few of the intervals, but we didn't merge all the intervals. That's a problem. So how can we do this? So a very basic intuition here comes up that we need to understand what should come first. So what should come first is what interval starts first. So what interval start first, we are going ahead to take that interval, and post upon we'll take the next interval, which is among the rest n-1 intervals, which is starting first. So once we have these two very first intervals, we'll understand and merge it out. Then we go ahead, we understand that the resultant interval, is it, can it be merged with next, and so on and so forth. Likewise, we'll do until and unless the entire array is completed. So for that, there are a few steps that we need to do. Is make the input interval sorted in a fashion where we have smaller intervals or first coming intervals, or the intervals which start earlier, which should be in the which should occur first within the input, and then consider if we can merge the intervals bit by bit, no, not bit by bit, one by one. Bit might indulge, bit might provide any other meaning. We are not talking about the computer bits, we are talking one by one. So make the input arrays sorted, and once we are done, return the result. So within these 3 steps, we would be covered upon how we are going to merge the overlap. So let's take this first one by one steps and let's start. So initially I'll make it in a sorted fashion where I'll input an array. I'll have 2 elements, I and j, from this, and obviously these are the arrays. So I want underscore I of 0 minus underscore j of 0. So post doing this, I'm making sure that first starting would be first in array. So cool. As we are running for merged intervals, I need a data structure to store this, and they want me to use linked list. They want me to use array list. I'll use array list. First step is completed. Good. Now we wanted to go ahead to the next step. The next step, it requires us to consider one by one and check if we can merge it or not. But initially, what we are going to consider with. So let's go back to our example. If we were having this intervals array, I was considering 1 3 to compare 1 3 with 2 4, and then I would perform the operations, maybe, may not be. But before jumping upon performing an operation, I considered one value. So let's consider one value from here. So int last value I'm taking as a of 0, and I'm considering the rest of the elements from there. Since I'm considering 0 as the last, I'm considering 1 as the next element. So it would be a dot length I plus plus. And since I don't want to alter this array, I'll clone this. Now check for if merging. So for merging, there can be either of few possibilities, like this is one interval and this is other interval. Either they can be exactly equal, that can be one chance. It can be one chance that I'll mark it as C1, chance 1, or they can be in such a way, or they can be in such a way. That means either we have a next upcoming interval C2, which would expand which would go beyond the ending point would be beyond, but the starting would be still within the range of initial, last. Or it can be happen that the initial and last, the new upcoming interval completely is within the range of first and last. So it would be something like this, like this, like this, and like this. So this is so tiny interval, and this fits right within this. There cannot be any of the case where we second interval starts first and then it ends in between or beyond the end, because we are sorted and we don't expect that the next upcoming interval would start earlier than this. So that is one more reason why we are taking it as a sorted. This lowers our headache. So let's deduce a conclusion before writing a code, that we have to have the last end should be lesser than incoming requests start. So either it is lesser than or equal to. So I'll consider this as last I'm talking about, and rest is the incoming. C1 incoming, C2 incoming, and this is C3 incoming. And in all of these cases, one thing is common for sure, that everyone has a last dot end is less than equal to incoming start. Cool. So what we can do however is we can go ahead and check last dot end is denoted by 1, is lesser than or equal to, greater than or equal to, my bad, I was considering greater than or equal to, because we want last is greater than or equal to the start. Incoming, what is incoming is the ith, so a of I, which is incoming of start. So if this is true, we are sure that it is, we need to go ahead and merging. So this is a merging point. What we want to do is we wanted to merge. So let's take this example, C2. So if I have last like this, and okay, wait a minute, last like this and C2 like this, incoming like this, the ultimate result would be from here, this point, up till this point. That means maximum of the ends and minimum of the starts. So I'll take the minimum of the starts, which is optional because we already know we are having minimal. Why? Because last is previously and we have sorted based on start points. So forget about start points because we are sure to have minimal in the place of last. This is one more thing why sorting helped us, where sorting helped us. Now I'm just considering the ending point. Ending point must be maximum of last of one comma a of I of 1. Now done merge. So we are done here. We did a merge. So continue to the list, to the next value. But what if didn't match, didn't intersect? So what if they didn't intersect? What do you wanted to do in such case? We wanted to store this into the result. So add the last, and now go ahead and check bit by bit. But wait a second, one by one I'm checking a new incoming. What would be my last? So my last would be a of I dot clone. Again, why clone? I don't want to go ahead and make changes within the current array which they have provided. And lastly, they would go ahead, check the last, and the loop would continue. The moment loop breaks, I wanted to just go ahead and store the last element and ultimately return the result, which is return res. Let's compile this one. Why I'm storing the result in the last? Because remember that I have copied the last value, but there was never a moment I stored the last within the result array. So I'm storing the last value within the result array over here outside the loop. Okay, it is not array, it is arrays. My bad. Okay, it compiled well. Now let's try to submit this one. Cool. It ran successfully. Yeah. So this was a very good problem for scheduling, or I would say not scheduling. This was a very good problem of greedy algorithms. I'm sorry. Whenever I see greedy algorithms, it comes into my mind as scheduling. Uh, but hey, why not? If you wanted to see more of the greedy algorithms, click the video on your right, and I'll see you in the next one.